So, Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we will start with chapter 2, lesson 1, the function and continuity. So, before we start, we need to know what is the meaning of a relation. Relation. If you remember the relation or the function, the domain and the range, that's all of the point that we need to revise. What is the meaning of relation? Give me any definition. What do you mean? What do you know about the relation? That's an algebra
One
one.
thing connected to another?
Again?
One thing connected to another?
Yes, connection between two sets X and Y. X connected with Y. So that's meaning by relation. Relation is a connection between two sets X and Y. X is defined by domain. The first set defined by the domain. And Y defined by
range.
range. So the relation is a connection between two sets X and Y, where X is the domain and Y is the range. From the domain, from the relation, we have a special case, which is a function. So what is the meaning of a function? What do you know about the function? Even if the definition is right or wrong, no problem for me. But just give me, but after that, after I'm telling you the right definition, you have to know the right definition. But just give me what you know about the function now. What do you know about the function? Function.
Value of y in relation to x?
A value, again, please. Value?
The value of y in relation to x?
Of y with relation? With x? Like that?
Yeah.
Do you have any other definition? A function. Give me any definition of the function. What do you know about the word function? When you hear the word function, what do you imagine from the word function? I don't need the exact definition. Just give me what in f of x. One of the. What is the meaning of f of x? What you will find from f of x?
Value of y.
A value of y. That's f of x to find the value of y. So we have a difference between y equals 3x plus 5 and f of x equals 3x plus 5. What is the difference between them? What is the difference between them? When you say that I need f of x which is y or y which is f of x, what is the difference between them? Give me, we need to think together. Even if the answer is right or wrong, no problem. We need just to think together to get the information.
The function is in terms of one variable only?
Again, please. I didn't get what you say.
The function is in terms of one variable x?
The function is when one variable is, you are close to it. The function is depend on x. So x is independent and y is dependent. Y is dependent, or the function is dependent on x. So the difference between, okay, so we can go back to the point y and f of x. The difference between the first one, we have y equals 3x plus 5. In this form, we can say that's called equation. But if I say f of x equals 3x plus 5, that's defined by function. So we can say that the function as a machine, just we put the value of x and we get the value of y. Did you get the same product from all machines, from different machines?
No.
The product depends on the material that you use and the machine. Is it right? So the answer that you will get depends on two ways. How the input, which is x, and which type of machines you are putting in machine of the first degree or the second degree or the third degree. It's depend. That is the meaning of the function. The function is a machine. By changing the form of the function, the answer that you get from 3x plus 5 is different than the answer that you will get from f of x equal 3x to the power 2 minus 5. The different answer. That's right. They are different. So the answer that you'll get, or the product, sorry?
Your voice is lagging.
The voice is lagging. It's okay now or not? Is it okay?
Yeah.
I don't know why at this time, exactly at this time, the voice is lagging. I don't know why. That's happening even
yeah, it's still
with
lagging a lot.
it's lagging again now. I don't know why this time.
Yeah,
Even in the session of grade 10, it's lagging at this time. I think grade 10 or grade 9. Sorry, grade 9. It's lagging at the same time. Type. So we can say that the function
Probably
is
internet traffic.
okay. Maybe you know that most of the students are joining at the same time. Okay. So we can say that the function is relation because we say that the function is a type of relations. So we can say that the function is a relation between x and y, in which each element of x connected just one time with the element of y. So again, now the function is the first point that we have the function.
Sorry.
So I close my videos and find the best internet. If you are not using your mic, please close your mic. If you are not using the mic, please close your mic. So we said that the function is, the first point of the function, that the function is a relation. And we said the relation is a connection between x and y. The second point of the function, or the second point of the definition, that each element of x connected with element with y. Each element of x must be connected with the element of y. The third point, each element of x connected one time, only one time. What is the meaning of that? It means if you have a relation, you can write a relation in different ways. One of the ways that you can represent by using mapping, that's called mapping. So the first point here, you need to check that all of the elements of x connected has image of y. Yeah, there is 1 connected with element, 2 is connected with element, 3 is connected with element. You understand this point? Each element of the domain must have the image at the range. Each element of the domain connected with the element of the range. And each element of the domain connected only one time. There is no 2 arrows going from 1 or from 2 or from 3. Only one. There is only one arrow is coming from 1 and 2 and 3. You understand it? They are going to which element? It doesn't matter. The main point that each element of x has only one image at y. Any problem for this one?
No.
Is that clear? So the function is a relation in which each element of x has exactly one image at the element of y. So for the function, we have two types of the function, and it could be both of them or neither. One of the type of the function is called one-to-one function. What is the meaning of one-to-one function? One-to-one function, if each element of the domain has exactly one unique element of the range. What is the meaning of that? It's mean, can you write the order pair for this one? Can you write the order pair for this relation or this function? The ordered pairs, 1 and D, that's the first ordered pair. The second,
2 and B.
2 and B,
3 and A.
3 and A.
3 and A. If you look at this relation, you will find that there is no element of X connected with the same, two elements of X connected with the same element. 1 connected with D, 2 and B, 3 and A. It means there is no two image with there is no one image for two numbers of the two elements of the X. Again, for this one, each element of X has different image at Y, different image. That's unique image for this one. You understand? That's defined by one-to-one function. So if you know, if you need to check if this function is one-to-one or not one-to-one, just look at the domain. Look at the domain and going to the range. Is there two elements of the domain connected with the same number or connected with the same element of the range or not? If each of them connected with different element of the range, then it will be in one-to-one function. Any problem? Any problem for this one? Okay.
Can you
So
repeat?
that again for this one, we need to check if the relation is one-to-one or not one-to-one function. So the main point that we start from the domain. At the first, we need to check if this relation is a function or not. Check, is there any element doesn't connect with the, for the domain, doesn't connect with the element of the range? No, all of them connected. Is there any element connected twice? Yani one is going 2 hours from 1 or from 2 or from 3 more
No,
than
sir.
one time? No. So this relation is a function.
No.
Now we know that the rest of the relation is a function. So how we know that this relation is one-to-one function? To know if this relation is one-to-one function, just look at the domain. Then check if there is more than one element of the domain connected with the same element of Y or not. 1 is connected with D. 2 is connected with B. 3 is connected with A. It's mean they are connected with different numbers. Is that right? Or different elements.
Yes.
So it's mean one-to-one function. Suppose that I have a number here is called 4, and the 4 connected with A. Can we say that this one is one-to-one function? This relation is a function because each element of the domain has an image. This relation now is a function, but this relation is not one-to-one function. Why? Because 3 is connected with A, and the 4 also connected with A. So now we have 2 elements of the domain have the same image of Y or the range. You understand it? To be one-to-one function, each element of the domain must have the unique element of the range. That is the meaning of one-to-one function.
Okay.
Number 2, onto function. What is the meaning of onto function? That for each element of the range, for if you want to start from the onto function, you have to start from the range. Each element of the range has corresponding element of the domain. We use all of the elements of the range. If you use all of the element of the range, it means, is there any element of the range we didn't use? Is there any element of the range we didn't use it? No, we use all of them. So this relation is onto function. But if we have here a letter A, can we say this one is onto function? No, because we have A doesn't connect. There is no corresponding one. There is no corresponding in the domain. You understand it?
Yes.
So the third type that we have now, it will be both of them. Both is one-to-one and onto function. How we know that? If each element of the domain, look at the domain, all of them has unique image of the range. They are different. They connected with different elements. And all of the element of the range, we use it. There is corresponding elements at the domain. It means this relation will be one-to-one function and onto function. At most of the cases, at all cases, you will find that the number of elements of the domain must be equal to the number of elements of the range. By the way, it's not necessary that all of the elements of the domain equal to, if all elements of the domain equal all of the elements of the range, it will be one-to-one and onto. Suppose that I have here 5 and I have here E. If 5 connected with A, now it will be?
Onto function.
Onto.
This one will be onto function?
Oh no, one-to-one, mister.
One-to-one function?
One is not corresponding. Yeah, one-to-one.
That's one-to-one function, are you sure?
One-to-one, yeah.
No, mister, it's onto.
It's onto function? What is the difference between one? No, it's a function. Number one, again, please. What is the meaning? My question is, why this relation is a function? It's a function, it's not function. Again, for this one, how you know that this relation is a function or not? To know if this relation is a function, look at the domain. Look at the domain. That all of the element of the domain connected with the element of range or not? Does all of the element of the domain?
Yes.
1 is connected, 2 is connected, 3, 4, 5. Did you find that any element of the domain connected more than one time? 1 is connected more than one time, 2 is connected more than time. Don't look where they are going, even if all of them connected to the same number. Suppose that all of them connected to A. All of them connected to A. This relation is still function. The main point that, is there any one of them connected twice?
No.
No. So this relation now will be function. You know when we can say that this relation is a function or not? If all of
Yes.
the element of the domain
Yeah.
connected, and all of the element of the domain connected to only one time. All of the element of the domain must be connected and only connected just one time. Now, how we know that this relation is one-to-one function or onto function? One-to-one function. Now, look at the ordered pair that we have now. We have 1 and D. The second one, 2 and B. The third one, 3 and C. Number 4, 4 and A. Number 5 is 5 and A. 5 and A also.
So 1 to 1.
It's not one-to-one.
Well,
Why
it's
not
onto
one-to-one? My
Because
question,
for-
this one is one-to-one or not one-to-one? Now, this relation now.
Not one.
Not one-to-one. Why? Because we have 4
Because
connected
4
with
and 5
A.
are connected.
5 is connected with A.
See.
So now we have the same image for 2 different elements of the domain. The same image for 2 different elements of the domain. To be one-to-one, each element has unique image. If we look together to the mirror, we will find 2 different images. Is that right? If we look together to the mirror, we will find 2 different images.
Yes.
And
So
one
if you
to
find,
one.
yes, 2 different images.
Yeah.
According to the number of persons, if we are 2, then we have 2 different images. 3, we have 3 different
Okay.
images. You understand it? That's one-to-one. But if you find that the same
Yeah.
image is repeated, it's mean this relation is not one-to-one.
Not one
Plus-
to one.
Okay. Now we need to check. This one is not one-to-one. Again, the new one that I draw it now, because when I have 5 and A, and E, if this relation is onto function, this one, the new one with 5 and E, if this relation is onto function,
No, because E doesn't correspond to the
yes,
domain.
that's one.
Oh,
This one is
it's
not
neither.
onto function. This one is not onto because E is not corresponding to any element of the domain. We didn't use E as an image. To be onto, you have to use all of the images. There is one element here without image. There is no image. There is image without corresponding element of the domain. It means this relation is not onto function. So it's not one-to-one. It's not onto. So it will be
Neither.
neither. You understand this one?
Yes.
Understand it?
Okay,
But
sir,
if
for the
I
first one,
remove sorry.
for the first one, C also doesn't have a domain.
Which one? So I didn't say that's onto. It's one-to-one. Again, what is the meaning
okay,
of
so why
one-to-one?
can't it be the same for the last one?
Which one?
So each domain has its own range.
Yes. So it would be one-to-one.
Okay. Yeah, but in the last one, you said E doesn't have a domain. So you said it's neither.
Yes.
Okay, so why isn't the first one neither as well?
Look at this one. What is the difference between that? Now we have for the first one, 1 connected with D, 2 connected with B,
Okay.
3 connected with E. Is there any image repeated? Is there any repeated image?
No.
No. So it will be one-to-one. Is there any repeated image here? 4
Yeah,
connected with
5 and
A,
A.
5 connected with A. So we have the same image for 2 different numbers. So it's not one-to-one.
While E is left alone. Yeah, okay.
This one, number 1. This one is not one-to-one function. Why is not one-to-one function? Because we have the same image for 2 different numbers.
Okay.
خلاص? That's the first point. Number 2, why it's not onto? Because E is left alone.
Okay.
You understand? Please be careful about this point. You understand the difference between them? What if I remove 5 and E? If I remove 5 and E, number 1, each element of the domain has unique image. Is that right? They are connected with different images. Is that right?
Yeah.
Yes.
So it's one-to-one. Each element of the range we connected has a corresponding at the domain. Is that right? We use all of the element of the range.
Yeah.
Yes.
So it will be onto. Because it's a one-to-one and onto, so it will be both of them. You understand the difference now between them?
Yeah.
Yes, sir.
They are different questions. So you have to know that if the relation is one-to-one, onto, or both, or neither. So for the first question that we have, we need to state the domain, the range of each relation. For any relation, we can find the domain and the range. Then determine whether this relation is a function or not. If that's function, determine if that's one-to-one, onto, or both, or neither. So number one, we need to find the domain. What is the domain?
-6.
Yes, just 1 minute. To write the domain, please write it between the two braces. Again, for this one, there is a difference between the brackets by this way, or the parentheses, and the braces, and this one, and that one. What is the difference between them? The first one, we use it for. Did you see this shape before?
Solution pairs.
No.
Pairs.
For the
I mean,
vector,
wait.
for the translation, if you remember, translation. If you have a point, X and Y, you need to find its image by translation A and B. So the image will be
Oh, yes, yes.
X plus A and Y plus B. This form, we use it for the vector. Any problem?
Yes, sir.
This one, if I write A and B
No.
by this way, it's represented by the ordered pair. So we are going A to the right and B up, so it's represented by only 1 point. But if I write here A and B, so for this one, it can be represented by on the number line as A and B, 2 points. But for the last one, if I said A and B, it's represented by interval, starting from A and end at B. That's the difference between them. Each bracket has different name. You understand that?
Yes.
You know
Yes,
the difference
yes.
between the
So,
brackets?
Mr.
Huh?
Yes. So the domain will be all the first A's. So -6, -5, -3, -1, and 6.
Without repeating. Don't repeat
Yes,
any
without
element. Okay? For any set, if you want to
Okay,
write
so
any
yeah,
set,
so the domain will be
the
the first
domain
A.
also, the domain at all cases, the domain is X. We said, if you remember from the beginning, we said that the
Yeah.
relation is connection between X and Y. X defined by the domain and Y defined by the range. So what is the domain that we have now? Will be -6,
Yes.
-5,
-6,
-3,
-3,
-1,
-1,
and a positive
and
6.
6.
Okay. So now we need to find the range.
-1,
-1, -9,
-1,
-9,
-9, -7,
-7,
and 7.
and a
positive
positive 7.
and
And
-9.
No.
though we
ended
said
7.
negative
We ended
9,
7.
Oh wait, 7 is repeated.
no,
We ended 7 خلاص.
end at 7.
Because
Negative
-9 is
7 and
repeated.
7
Yeah,
are
that's it.
different. But -9 here is
Oh yeah,
repeated.
my bad.
-9
So
repeated.
we'll stop for this one.
So yeah, it's,
Okay. So is this relation is a
so
function
No,
or
it's
not?
not one-to-one.
Is this
Not one-to-one.
question number 1? Is this relation is a function or not function? That's the first one. State
Yes,
the
yes,
domain.
yes, it is a function.
Question number
Yes,
2
function.
state if this relation is a
Yes.
function or not. So it will be function. Why function?
Yes, it is.
Because each domain
Because the
element
domain
has
is paired with one
corresponding
element.
Yes, because
line.
the domain is connected only one time. We didn't repeat any element for the
Yes.
domain. Number 2, this relation is one-to-one function.
No.
No.
It's not one-to-one. Not one-to-one. Why it's not one-to-one?
Because one is repeated, -9.
5
That's
is
repeated.
connected with -9. 6 is connected with -9.
6 is
It's
connected with
mean we
-9.
have two elements of the domain have the same image. Have the same
Yes.
image of the range. So it's not one-to-one. Just 1 minute. Type. Now we need to go back to this relation is onto function or not?
Yes.
Question number
Yes.
1, this 2, and that 3. Why you know that's onto function?
Because
Because
two of
each
the domains are
each
connected
element
to the
corresponds
same
to
image.
a domain element.
Because we use all of the elements of
Y.
all of the element of Y. Any problem for this one?
No.
No, sir.
Okay, for question number 2, we need to find the domain.
-2, -1,
Domain.
and 2.
Just 1 minute. 2 and the -1.
-1.
-1,
And
-2,
Hmm?
and
And
negative
2.
Oh, but
That's it. That's it.
That's it, because we said -1
yeah.
before, so
Because
I
it's
will not
repeated.
write it again. 2, I
Yes.
will not
So
write
it's
it
not a
again.
function.
So I need to find the range.
negative
What's the
2,
range?
negative 2,
-2, -1,
-1, 0, 1
Zero.
and 2.
1 and
1
2.
and 2. This relation is a function or not function?
No.
No,
No.
Not
because the
function.
domain
Why
is
not
repeated.
function?
because
Domain is
2
repeated.
is repeated and 1 is
Because
repeated twice.
we have here the same element repeated for the x. We repeat the same
Yes.
element. Now we have two elements
Yes,
connected
yes.
twice. Malum?
Yes.
Well,
Yes.
Okay, number 3. Because it's not function, so we can't say it's 1 to 1 or on to, because from the beginning it's not function. We just say if that's on to or 1 to 1, if that's only if the relation is a function. Type number 3.
2.
Number 3 at the first we need to write the ordered pairs. What is the ordered pair that we have for this one?
0, 2.
0, 2.
Start
1,
from the left.
2.
Start from the left instead
Okay.
of forgetting
Negative
anyone.
3
So
and
to
2.
negative 3 and
Negative
2.
3,
Negative 3,
Negative 3 and
Negative 2
2.
and 1.
2.
Negative 2,
Negative 2 and negative 1.
Negative 2 and 1.
Negative 1.
Negative 2
Oh, yeah.
and
Negative 2 and
negative 2.
Yeah.
Negative 1 and 1. Just find the order base.
0 and 2.
A,
yes, yes,
B,
yes. And 0 and 2.
C, D,
Yes,
E, F, G to move in order. F,
0 and 2.
0 and 2.
0 and 2.
1 and negative 2.
1 and negative 2.
3 and negative 3.
4.
3 and negative
Oh,
3.
4. My bad. Sorry.
4 and
No,
negative
no, no. 4, 4,
1,
4.
2, 3, 3. 3 and negative 3.
1.
G.
My
G,
God.
G, 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 not H. G.
4
1,
and
2,
4.
3, and going down 3.
yes.
That's
4
4 and 4.
4.
Okay.
Sorry.
So we need to find the domain.
Negative 3.
Negative 3.
Negative 3.
Negative
Negative
2.
2.
Negative
Negative
1.
1.
0.
0.
1.
1.
3.
3.
And
3.
4.
4.
The range.
Not
2,
2.
1, negative
1.
2, 1.
Negative 2.
Negative 2.
Negative 3, 4.
2. Negative 3.
Negative 3.
Negative 2. Was it 1, 2 again? Negative 3.
Negative 3 and 4.
And 4.
And 4.
So
No,
it's not function.
Not a function.
Not function.
Any problem for this one?
No.
No.
No problem.
For number
Is there a way
4?
to tell without, Mr. Islam, can't you tell it's not a function from the graph?
Yes, from the graph we can
Because,
find it because we have two with the
there's
same.
2 points in a vertical line.
But if you go to the question, number 1, state the domain and range.
Oh, okay.
Okay. After stating the domain and range, then read the question, then determine whether the relation is a function or not. So even if the relation is not
Okay.
function, I need to find the domain and range.
All right.
Can you go up a bit?
You understand it?
Yeah.
Is it clear now? Number 1, the question required to find the domain and range. So even if the relation is a function or not function, I need to find the domain and range. So for number 4, the domain, that is the domain,
Number 3.
that is the domain, and that is the range.
Yes.
خلاص. That is the
Negative
domain
3,
and that's the
negative
range.
2.
Okay. So
Function,
Neither.
not
Neither.
1 to 1.
it's function or not function?
Function,
Function.
but not 1 to 1.
It's a function.
Not 1 to 1.
Is it 1 to 1?
No.
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 Okay. Is it on to function? Why
No.
it's not 1 to 1? Why it's not 1 to 1?
Because 6 has 2 domain
6
elements.
the image of
Has
2 elements of the
Negative
domain.
1.
Okay.
Yeah.
Why is this one is not onto function?
Because
Because 8 doesn't have
Because
corresponding
8 is not
elements.
used.
Left out.
8 is not used.
Yeah.
8 is left out. 8 has no corresponding of the domain. I think
So
now
neither.
it's on. Yes, it's neither. Any problem for this one?
No.
Okay. So we have the discrete and the continuous function. What is the meaning of that? If you just graph the function as a point, like the point that we have only you have ordered pair, it will be discrete function. But if you start graphing whatever the graph that you have, even if that's line, if that's broken line, if that's curve, if that's circle, if you just start drawing the function without removing the bin That means this function is continuous relation. You know that's the difference between them now? If you just graphing any function,
Wait,
the
wait,
graph,
sir, could you repeat?
I don't.
again for this one, what you find here? Points. Is this point connected together,
Point.
or there is a gaps between them?
No.
No what? My
There's
question.
Yeah,
gaps.
so discrete.
There is gap, so it will be discrete for relation.
No.
You understand it
Yeah,
now?
there is gaps.
Okay. Is there any gap here?
Yes, sir. No.
There is no gaps.
So continuous. It continues.
So it will be continuous. If you just start graphing,
Okay.
when I ask you to graph this relation number 2, or graph B, when I ask you to graph it, when you just put the pen, you will start to continue graphing until you finish the graph. Then you remove the pen. So it will be continuous relation. You know now the difference between them? But when I ask you to graph this relation, you have to put the point, then removing the pen, then again put the point, then removing the pen. You understand it?
Yes, sir.
Okay.
I'll understand if we solve the question.
Sorry?
I'll understand if we solve a question. I don't understand like this. I didn't understand it.
Again for this one. Is this relation connected together? This point, this connected together? There is a gaps between them?
Yes.
So it's called discrete. Now if you want to graph a line, how you can graph the line? Just if you put the pen on the paper, you will not remove the pen. Is that right?
Yes.
So it's continuous. There is no gaps. Well, I didn't say anything hardly. So we have here the vertical line test. What is the meaning of vertical line test? The vertical line test that we use it to check if this relation is a function or not. What is the meaning of the vertical line test again? The vertical line test, if you can draw any vertical line, intersect the graph or intersect the relation at more than one vertical point, or there is more than one vertical point lies on the same vertical line, it means this relation is not function. Again for this one. Again for this one. For the relation number 1, if you draw any vertical for relation number 1, if you draw any vertical line, it will intersect the graph at exactly one point. Can you draw any vertical line? Please don't say I will draw a line like that. Please, my question is, can you draw a vertical line intersect this graph at more than one point?
No.
No, sir.
So
No,
this
you can't.
relation is a function.
No.
You can? Who said it can? If you can just draw it, please, and send it to me. خلاص? It's easy. You said I can. خلاص, draw it and send it to me to prove it.
Yeah, Mr. I said you can't.
There is one say I can.
Oh, okay.
Okay, this one.
No one said that.
No one, maybe my mistake. Okay. So if you can't draw any vertical line, if all of that vertical line intersect the graph at exactly one point, so this relation will be a function. For any line here, if you draw any vertical line, it will intersect the graph at two vertical points or more than one vertical point. Because the graph, there is two vertical point lies in, there is 2 point lies in the same vertical line. It means this relation is not function with an easy
Not a
way.
function.
So that's the meaning of the vertical line test. You know why the problem
Okay.
when I say that if you can draw a vertical line? Because wallahi, I stay more than 10 minutes or 15 minutes with one grade to explain that there is difference between. They are saying that I will draw a line like that. I said this line is horizontal line. He said
Yeah.
that's line. We can intersect the graph at 2 points. So another one said that I can draw it by this way. I said please. I said vertical line. So at this point I become nervous one line. So we need to graph this relation. What is the type of this relation? Y equals 1 over 2x minus 3. What is the type of this relation? If you remember,
Slope-intercept form.
it's a form.
Slope-intercept form.
Slope-intercept form of which relation? Which function? I didn't ask you what is the name of the form. What is the name of this relation?
Linear equation.
Linear. That's what I need. This relation is linear. How you know that's linear?
To the first
Also-
degree.
of the first degree. Again, just we need to put the point. When I say y equals 1 over 2 x power 2 minus 3, I keep the same in the slope intercept form, the same. This relation is a linear. This relation is linear. It's written in the form y equals mx power 2 minus 3 minus p. Huh?
Not linear.
No, why not linear?
Because second degree.
Yes, that's what I need. When I ask you what is the type of this relation, so you have to say that it's linear. Why you know
Okay,
that it's linear? Because
first
it's
degree.
of the first degree. What is the graph of the first degree? It's represented by a straight line. So how we can
Yes.
graph this one?
-3 is the b.
Okay, so at the
And
first we
equals
will find the slope, which is 1 over 2, and the
B
y-intercept
equals
equals -3. So how we can graph this one?
At the point -3.
I will start from -3, going up 1, and
And
right
2 to the right.
2. So now we will graph the relation that we have. Any problem now for this one?
No, sir.
This relation
Mr.
now
I
we
have,
graph. What?
Mr. I have a question.
What?
So if the equation has three numbers, like half and -3, and also +5, how can you graph that?
Which one? You have to write the like term, adding like terms. Please, please, please. If you find any question, give it me and I will solve it.
Okay. Can I
Okay.
send you the question on Telegram?
Send me the question now and I will solve it now.
Okay. Okay.
خلاص? No, you will write it. Just 1 minute. You will write the question. I said if you find a question, it's mean from the book. Just take a screenshot from the book. Take a picture
Yes.
from a book.
Yeah. In the book.
From the book.
Yes.
Okay. From any book. Even not our book, no problem. But from a book. خلاص? Okay. So now for this one. Is this relation is a function or not
Yes,
function?
special.
This relation is a function or not function? Number one, we graph. Number two, we need to find the domain and range. What is the domain for this one? What is the domain for this function?
Yes, it's because yes.
Function, yeah.
Question number two, what is the term and the domain and range? The question number one, graph. We graph it. That's number
First,
one.
we find the points. Let's find the
Number
point.
two, this continuous function. So if you want to find
find the
all of
point?
the numbers, that's continuous function. If you want to find all of the number, there's infinite number of numbers. Infinite, that's straight line. What is the meaning of a straight line? What is the meaning of the
How many
straight
do we
line?
need?
A straight line is formed from infinite number of points.
Yes.
Is that right? So we will not write all of the points. So what is the domain? What is the meaning of the
All
domain?
real numbers?
With an easy way, what
all
is the
real
meaning of the
numbers?
domain? It's all real number. But what is the
X
meaning? My
value.
question now. Domain.
Next value.
Yes.
X
Domain.
-1,
is-
0, and 1.
No, we use -1, 0, and 1 to find the graph and represent it.
Okay.
You understand it? We use only these values to graph the. It's help us to graph the line, but the line will be it's straight line. It's straight line is formed from infinite number of points. Where is the starting point? Where is the end point? At the first, I will just give you the definition, then we can go. What is the meaning of the domain? Domain, that's all of the value that you can use instead of x. Which value that you can use instead of x? Is there any exception for this one? Is there any value for x that you can't use?
No.
Can you use x equals fraction? Yes. Can you use x equals?
Yeah.
If you use x equal fraction, is it gives you a result or not?
Thus.
Yeah.
Yes. Whatever the value that you will get, even if that's fraction, rational, irrational, whatever the value.
Or negative.
This number, positive. Can you use a positive number? You can use all of
Yes.
the positive number. Can you
Yes.
use a negative number? You can use it. Can you use
Yes.
zero? Yes, I can use. Can I use decimal and fraction? Yes. Can I use roots?
Yes,
Even
yes.
you can use roots. So it's mean you
Yes.
can use all numbers. So it's mean the domain is R. What is the meaning of the range?
Oh, the domain is all real numbers.
Yes, the domain
Yes.
for this one is, I will explain how you find
Oh,
it from the
okay, yeah.
graph. What is the meaning? I just
Yes, sir, I got
talk
this. I
about
remember
the
it.
meaning of the range. The range, that's the answer that you will get from the relation. But after substitution, the answer that you will get, that's called range. So what is the answer that you will find? You can find a positive number. You can find negative number. You can find
Negative.
zero. You can find a fraction. You can find decimal. If you use root, you will
So it's
find
also
the answer
R.
is root. So it's also R. So how we can find it from the
Okay.
graph? You know the meaning now for the domain and the range?
Yes, sir.
Okay.
Yeah.
Well, how we can find it from the graph? To find the domain, we said the domain with X, the range with
Y.
Y. So if you want to find the domain, look at X. If you want to find the range, look at Y. So now we are
Okay.
looking to X. I'm looking horizontally. If you start here, you will start the graph. To know the domain and range, domain, you have to start from left to right. Range from down to up. From the smallest to the greatest. Okay? From the greatest, because we start here from the greatest from negative infinity to the positive infinity. And we start here Y from negative infinity to the positive infinity. If you look at the left, you will find that arrow. It means it's going to which number? To negative infinity.
Negative infinity.
Then we start from negative infinity. And if you look at the right, you will find that it ends with arrow. It means
Positive
it's
infinity.
end to the right, it's positive infinity.
Positive.
So it will be from positive infinity and negative infinity. What is the meaning? From negative infinity to positive infinity, it means you need all numbers. What is the meaning? All numbers, which is all real number, which is R. Now, if you want to find the range, how we can find the range? If you look at here, you will find that arrow. So range, we are looking to Y. Arrow, it means it's going down to negative infinity. And if you look up, you will find arrow. Arrow, we are looking to Y. So it will be positive infinity. So
Yes, sir.
from negative infinity to positive infinity, it's mean R. You understand now how we can find it? The domain,
Yes, sir.
we look at X.
Yes.
But the range, we're looking to Y.
Y.
Okay, this relation now, the function or not function?
Function, sir.
It's a function. Okay, so it's, I will write just 1 minute. This relation now is function. This relation is one-to-one or onto or both or neither.
One, I think.
It's both.
It's both. Why both? Your answer is right, huh?
Because both of them are one-to-one in the sense they have each unique
Yes.
pair.
We use, yes,
and it's
each
onto as
element.
well.
Each element of X has only unique image. You didn't find the same image?
Yes.
Okay. And we use all of the values of the range. Because we say the range is
Yes.
R. We use all of the values of the range. There is no exception for the range.
Yes.
It means this relation will be
So it's both.
both of them.
Both.
It will be discrete or continuous function.
Continuous.
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 Because because when you graph the function, we start from the beginning to the left and without removing the pen. Just 1 minute to check the question that Abdullah sent it. That's inequality, Abdullah. That's a different question.
Yes.
That's inequality. That's different question. That's
Yeah, but
different lesson.
it's also in yeah, but it's also in 1.7. Like, but I don't understand this one.
That's different. Listen. Go back to the lesson. I will send you the video. Just check for the video and you will find the explanation. That's different. Listen. We finished
Yes,
this
I
lesson.
understand. But
You ask about this one. Just 1 minute. This one. 1.7.
yes,
We finished this
I
lesson.
understand.
We finished. So that's the graph. They are different questions. So I will send you the video. I will send you the video
Okay.
for this one. Okay. You will find it. I think that's I sent it. I sent this video. That's right.
Yes, sir. It's on
1.1
Telegram.
on Telegram. 1.7. Just go to the video and check how we can solve it.
Okay.
We finished 1.7, 1.8, 1.9, and that's 2.1. 4 lessons. Okay. So that's how we can find the relation. I need you just to graph y equals x power 2 plus 1. Then determine the domain, range, determine whether the equation is a function or not. One-to-one or onto or both of them or neither. Then,
Okay, sir.
okay.